Welcome to this Maths Made Easy video on integration by parts. And to start with, let's just give the result that we're going to use here for integration by parts. Now to start with, let's recall the product rule. So the product rule is d by dx here of uv, this product of functions here, u and v. And we'd write this here as u times the derivative of v with respect to x plus v times the derivative of u with respect to x, so du by dx there. Okay, so that's the product rule. Now integration by parts is the reverse of this. So in this case, so for integration by parts here, integration by parts, what we'll do is we'll denote this in a different colour just to highlight this. So let's say we do this in blue here. So integration by parts is the integral here of u dv dx, so dv by dx, and this is equal to uv minus the integral of v du dx here. Okay, so that's our result there for integration by parts. Now here, when we're using integration by parts, we want to choose u to be something that will differentiate nice and easy, for example. So here, we just change back to our original pen colour. Let's say we want to find the integral here of x sine x. Okay, so x sine x with respect to x. How would we do this? Well, first what we need to do is choose u. So here in this case, if we just take a look at this integral, I'm going to choose u to be x, because if we differentiate that, we get a nice straightforward result of 1. Okay, so if u is x, if we differentiate that, u prime, we simply get 1. Okay, and in that case then, my dv by dx is going to be sine x. Okay, so dv by dx, or v prime here, we could have wrote that as, is going to be sine x. Okay, so this is du by dx here. Write that in full as well. Okay, so dv by dx is sine x, so in that case we need v, and clearly if we've got dv by dx, to get v we just integrate here. Okay, so therefore v is going to be the integral of sine x, simply giving us minus cos x. Okay, so here now we can simply apply the result here of integration by parts using u, du by dx, dv by dx, and v. Okay, so therefore this integral here is simply going to give us, in that case, it's going to be minus cos x times x. That's going to be minus x cos x. That's minus x cos x. And then here we do minus the integral of v. So v is minus cos x. So in that case, that's going to be minus cos x. And then we times that by du by dx, which in this case is just 1. So that just gives us the integral of minus cos x with respect to x here. Okay, so this is for the integral now of x sine x with respect to x. Okay, and here now we can simplify. This is minus cos x, so we can apply linearity here and take this minus 1 outside, which in this case would make this plus the integral here of cos x. So therefore this is going to give us minus x cos x plus the integral of cos x with respect to x. Okay, and here now, to finish this, all we simply need to do now is integrate cos x with respect to x. Okay, and if we do that, we get minus x cos x here at the front still, and the integral of cos x with respect to x simply gives us sine x. Okay, and don't forget our original integral had no limits, so in that case we still need our constant of integration here, so plus c there. Okay, and that there is for the integral of x sine x there. Okay, with respect to x. So our result here is minus x cos x plus sine x plus c there. Okay, so that gives us the result for integration by parts. Moving on now to take a look at the integral of the natural logarithm. So here, if we wanted to find the integral of the natural logarithm of x, this is quite a tricky result here. However, by applying a clever trick here, we can go on to use integration by parts to find this integral. So here, what we're going to do is express this natural logarithm of x here as a product of 1 times the natural logarithm of x. So in that case, we can write this integral here as the integral of 1 times the natural logarithm of x here. Okay. And in that case now, we can go on to use integration by parts. So what we need to do here is choose u, and we need to choose dv by dx. Well, here, we need to choose u as the natural logarithm of x. So u is ln x. So in that case, if we differentiate this here with respect to x, we simply get 1 over x. So 1 over x there, for the differential of u with respect to x. And for dv by dx here, well, in that case, this would just be what's remaining here, which is 1. So that's 1. And to find v here, we just simply need to integrate here. So in that case, we get v. And if we integrate 1 here with respect to x, that simply gives us x. Okay? So what we've got here now is everything we need to go on to apply integration by parts. So here now, integrating this with respect to x and using integration by parts, we get u times v, which is x ln x. So that's the first part there, that's uv. And now we minus the integral here. In this case of v times du by dx, that's x times 1 over x. So x times 1 over x with respect to x here, and clearly x times 1 over x would just give us 1. So in this case here, this is x ln of x minus the integral of 1 there with respect to x. So here all we need to do now is work out this integral here of 1 with respect to x, which would clearly give us x there. Okay. So here, this is x ln x minus x here. And don't forget, we need our constant of integration, as we have no limits here on the integral. So we've got our plus c. And finally, we can just simplify this with one final line of working here by factoring out an x here. Okay, so in that case, we get x. Now a bracket here, we're going to get ln of x minus 1, and then don't forget our plus c there. Okay, and that gives us the result for the integral of the natural logarithm. And finally, taking a look now at integrating by parts multiple times. So in this example here, we're asked to find the integral of x squared times e to the x. So here, as this is a product here, we're going to need to use integration by parts. So here, let's define our u, which in this case we can set as x squared. That's easier here to differentiate. That gives us x squared for u. And if we differentiate that, du by dx here is simply 2x. Okay. We also need a dv by dx here. And our dv by dx is whatever's remaining, which is e to the x. So in that case then, to get v here, we just need to integrate with respect to x. That gives us v. And integrate here e to the x with respect to x to get e to the x. Okay. So now let's go on to integrate by parts here. So we find the integral here of x squared times e to the x with respect to x here. Well, in that case here now, applying integration by parts, that's going to be uv. So we're going to get x squared e to the x. And now we minus the integral here, in this case, of 2x times e to the x. So this is du by dx times v. So in that case, we get 2x e to the x with respect to x. Now normally here, we would just calculate this integral here, and we'd be on our way to finding the full integral. However, this part here, so we just notice in red here, this part here requires integration by parts again. Okay, so integrate by parts here. So again here, what we need to do now is define our u and our dv by dx. So what we'll do is we'll do this part in red just to make it clear. So u here, well again, what's the easiest thing to differentiate? Well, in this case, that's simply going to be 2x. Okay, so in that case, my u is 2x, and if we differentiate this here with respect to x, we get du by dx, and that's simply equal to 2. And now we need our dv by dx. So in that case, dv by dx is whatever's remaining, which again is simply e to the x. So that's e to the x. And again, if we integrate that to get v, just like we did for the first time round for integration by parts, we get e to the x. Okay. So here now, we still have this first part of x squared times e to the x, and now we've got minus this integral here, which is going to be using integration by parts. So let's just be careful here that we don't get tripped up And in this case here now, if we write this out in full, so if we keep the first part again in black here, just so we can see it clearly in black pen, so that's x squared e to the x. Now we've got minus this result here. Okay, so let's put a minus here on the outside. Well, let's put everything now back in red. So here, applying everything using integration by parts, we're going to get uv, so that's u times by v, so we're going to get 2x times e to the x here. That's 2x e to the x there, that's my uv. And now we minus the integral here. So we minus the integral here of du by dx times v, so that's going to be 2e to the x. Okay. Now here, just to make it clear, we've got this minus on the outside. So if we write everything out now back in our original pen colour here, we've got x squared e to the x minus 2x e to the x. And now minus this result here, so minus of a minus, that would just become a plus. So this is plus the integral of 2e to the x with respect to x. And in this case now, all we simply need to do here is find the integral of 2e to the x with respect to x. And that would just simply give us 2e to the x again. So therefore, our result here is simply going to be x squared e to the x minus 2x e to the x, and then plus 2e to the x. And finally, we can't forget our constant of integration, because again, we have no limits on the original integral. Okay, so this line here, if we just highlight this part here is our final solution there. Okay, and that gives us the solution there to our example here on integrating by parts multiple times. And that concludes this Maths Made Easy video on integration by parts.